Another thing that we talked about is a straight line would be really nice. However, they don't exist in the real world. If I have a store over there and I want to walk out of this window, I won't like it. So there are roads in the real world, and usually there are multiple paths that these roads have. Okay. Also, most roads are bidirectional. In a sense, you have a road which goes from A to B, and there's a parallel road B to A, which is on the same larger road. You can say it's been split into two pieces. We are not going to be considering that. We are not going to assume that if there is a road from A to B, we are going also from B to A. If there is a road, then please add it in the graph. The other thing that we said is we want to minimize time. Since we have only one factor which define the roads, you can use that single factor, an integer, to define the entire road, which means the time taken to move from a position X to a position Y is going to define the entire road, let's say 3 minutes, right? And we want to minimize time. And since we want to minimize time, our job is to find the minimum path from any source to destination. If I write any over here, it will be mathematically incorrect. It's not like any source possible. So for the source that you chose, your home, your office, to a destination, your home, office, restaurant, whatever. Okay, this looks pretty simple. It looks like all you have to do is run a graph algorithm and your job is done. But you have to look at the scale of the problem. The scale of the problem is absolutely massive. Firstly, the locations are not perfectly defined in terms of this road starts here, this road ends here, and the location is right here. The location could be in between the road. If you're going to your friend's house or even a restaurant, it might be in the middle of the road. So one of the challenges is you have locations which start in the middle of the road. This is much more likely than having things at the end of the road. And at the same time, you have sources. It's also true for the source, right? Destination, source, both can be in the middle of the road. The second problem is you have too many paths from source to destination. I've just drawn two possible paths, but imagine you're going from Mumbai to Pune. There's a highway and the highway takes little time, around I think 3 hours or something. But if you choose the other paths, it's not that you're not going to reach Pune. It's just that it's going to take forever. But that doesn't mean that you don't need to consider those paths, right? If you're starting from a position in Mumbai, let us say Powai, there's a particular way by which you'll reach the highway, and that will take you very close to Pune, and then it will take you to your destination in Pune. However, if you're starting in a place called Andheri, this is all stuff in Mumbai. So if you don't recognize, that's fine. You can think about your own city. And you have a position inside the city which takes you to the highway, and the highway is really fast, and then it takes you again to the destination inside the city. The problem here is not the highway. That is one of the few paths which will take you from A to B. The problem is these intercity destinations, intercity routes. These are potentially many. Yep. Literally thousands of ways to go from the highway to this place. Right? So how do you deal with this? You could say that for every single location that I'm adding on the map, I'm going to find every single route possible to every single destination on the planet. That's mad. That's insane. It's not going to happen. So we have to come up with a smarter algorithm. So for this, you have just one option, and that is called approximation. Till now, we are just focusing on one thing, which is routing from S to D. Our assumption is if we can solve this problem, then the rest of the problem will also be solvable. And we have come to the conclusion that if we can approximate a route from a position source to a position destination, then the problem is feasible. Okay, if you want to do it in the optimal way, optimal meaning the mathematical optimal time required from source to destination, that's not going to happen. There are too many possible paths from source to destination, so you can't do this. And there is another problem, of course, that the source and the destination may be in the middle of the road. So let's tackle the first problem. This is rather simple. If you are in the middle of the road, we will take an approximate time that it takes from this position to reach a corner point of the road. Okay, if you're on a road, let's say this is road X to Y, and you are in a location Z, then I'm going to say, tell me the time taken to reach a position X and reach a position Y. These are two things that you need to do. So you get two times over here. Let us say capital X and capital Y. This is time taken to reach X from Z and time taken to reach Y from Z. Amongst these, you can choose the minimum, or you can choose that particular time which takes you closer to your final destination. So you're over here in the source. There is one position X over here, position Y over here. This is capital Y, this is capital X. Maybe capital Y is smaller, but it's taking you away from your destination. So you just go for this one. Okay, that solves this problem of locations can be in the middle of the road. You convert your current location into the nearby corner point. Okay, maybe you have a turn over here. That's the reason why this road is considered ending over here. So what that implies is X and Y have multiple paths. Otherwise, you would just be heading in the same road. If you have no left or right option, then really ending the road here doesn't make sense. But if there is an option, then what you should be doing is you should be noting this position Y and then giving these options to any incoming traffic. So that means note all points on a road having multiple possibilities, which is basically turns, and mark them as limiters. So road from X to Y. Why not X to Q? Because you have a turn in between. So it will be X to Y and Y to Q. This allows us to find nearby limiter for source and destination. So even in the destination, you will have it in the middle of the road. You'll find the one which is closer to this point, X, and then you'll find the time taken to reach there, which is capital X. So maybe this is the nearest by limiting point. This will be added. So X of S plus X of D plus the total amount of time it will take for you to go from this limiting point to this limiting point. What we did very simply was to get rid of the problem that we might be starting or ending in the middle of the road, in the middle of some road. That is taken care of with this.